Okay, everybody, welcome back. We're now ready to start. Okay, welcome to our last panel of the day. Just before we move to that, I wanted to point out, and hoping this won't cause a huge exodus and run around the room, but we do have some charging possibilities at the back there. So if you want to charge your mobile phone, you don't need to look outside the room. At the back, we actually have a table that's full of connections for it. So our last panel is looking at smart airport safety solutions, and to run it, we have our moderator from EASA, Edouard Chofu, who is the head of department for aerodromes and air operations. Edouard.
Thank you very much, Janet, and good afternoon, colleagues. It's incredibly good to be again in a room full of people. I want to convey my thanks to our colleagues in the Czech Republic for hosting us again in the beautiful city of Prague. But also to all of you that took the trouble to travel here to be with us to discuss safety matters, which I believe that are more important than ever in the context of the recovery that we're seeing out of one crisis. I want to follow up on what was previously discussed, and this being the time of the year, getting to the closure of the year. It's the time when the words of the year are being chosen by different dictionaries out there. And one of those by, I think, Collins Dictionary is called perma-crisis. And we had seen it so vividly in terms of impact for aviation. We are all looking to recover from the most difficult one, the COVID crisis, at the same time landing in the middle of other two, or three, depending how you want to count them. And we've seen aviation being very resilient and being able to manage its risk. In the end, crisis is change management. It's perhaps the change you don't want, but it's a change that has to be managed no matter what. And what was not mentioned by the previous speakers, because they had very rich topics to cover in very little time, is that crises are also catalysts for progress, for innovation. And that's why we are here to look at innovation. We see one of the three big pillars mentioned by our colleagues from the ACI in terms of innovation being a solution to the challenges this sector has in front of it. And it's not only this, I would say, transitory challenge, crisis that we've seen and we are facing and we are proving fairly difficult to address, but also more existential and fundamental challenges in terms of aviation adjusting its environmental footprint and aviation being able to cope with ever-competing need of advancing human resources. And innovation is perhaps one of those solutions. Innovation may be not always the silver bullet. It has to to make sense. It has to deliver. And we also want to, with this panel, to demystify a bit innovation. It's a big word that can mean a lot of things. And now we have a panel of A-listers in terms of professional heavyweights that we have put here together. You see them on the screen out there and here on the panel. And they will introduce the solutions that they are actually developing, deploying in field, speaking about the challenges associated with those, also different perspectives. In the end, airports is where aviation comes together. So here is no different. We have, of course, airports, we have navigation service providers, we have airlines. They're all coming together in the airport, and they have to do this in a seamless way. I will not bore you too much with my own considerations because they have far better stories than me to tell. And I'll start first with Alessandro Fidato. He's Chief Operating Officer for SIA Airports Milano, so Linate and Malpensa. And we know that in Milano, you are undergoing a digital transformation. And how are you leveraging this digital data to transform your processes and ultimately enhance safety and efficiency?
Thank you, Edward. Well, first of all, let me say that COVID-19 has speeded up digital transformation and digital the development of digital technologies by several years. But actually, digital transformation is not technology. Digital transformation is a process transformation. And for Sea Island airports, what we have tried to do is basically to leverage data to transform processes. And the data also for company like airport management company are really, really important and are more and more a valuable asset, and they can determine the future of a company. And data for an airport are central both for, let's say, value creation, both in terms of cost saving and revenue generation, but also data for airports are central for enhancement of passenger experience and also for improving airport efficiency and safety. So what we are trying to do in SEA, let's say our strategy, is to try to extract data, to collect data at the airport from different data sources. I'm talking about transaction data, test data, video data, and localization data, and even sensor data. So this is part of our transition to Industry 4.0 world, where data are a must to improve your process and to be able to take decision on solid basis to do the best choice possible that you can do. So I will try to give you some examples in particular on sensor data, because I don't have the time to talk about everything, but sensor data, how we are using this data to improve operational efficiency and safety. So I will start with the runway pavement sensor that we use to measure the contaminants of the runway. And how important is that? Because the contaminants can influence the braking action of an aircraft, and which can determine even a runway excursion. So it's very important. And we started a trial last year for 4 months with our airport authority, ENAC, and we wanted to measure the accuracy of this data from the sensor compared to the measures that we were physically doing on the runway. And actually, after 4 months, we find out 100% accuracy of the data, and we decided to implement this system, to be fully compliant to Regulation 2148, and to determine the runway condition. So we are using this sensor, which are certified by EUROCAE AD292, and we, for example, in Malpensa, we have 2 runways of 4 kilometers. So we have placed 6 sensors per each third of a runway. 4 sensors determine the runway condition, and the 2 sensors are used to, actually it's a very technical issue. They're used to measure the freezing point, which is very important because it gives you information on the transition status of the contaminant, which is very important. As you know, water, wet, can turn into ice, and so you need to have the information, at the right time, because you need to use the icing liquid on the runway. So we are using this 6 sensors for each third of the runway, and then we are placing, in the strip, 3 weather stations. Also, the weather stations are equipped with weather sensor to measure humidity, pressure, temperature, wind, and the intensity and duration of rain. And there is also 1 sensor in the central position of the 3 weather stations which is a snow sensor, so measures the duration and intensity of snow. So while we are doing all this, these data are then sent to a cloud, where there is a server, and with algorithms are treated, this data, and then are sent directly to our control room, and visualized in the airport map, and then the control room checks the data and is able to issue the runway condition report or the SNOTAM, depending on the on the season, on the consistency of the contaminant. So why we are doing this? We're doing this because this data, with this system, we are able to detect all the different required parameters continuously. And we are able to send this data immediately to the control room. So it's not like when you have to do a measure, a direct physical measure, that you have to, go and your staff goes to the runway, talks with the tower, with the air traffic control, asking authorization to get in, and he said, okay, look, there are 3 landings for departure, so I give you a slot of 2 minutes in half an hour. So you have to wait half an hour before you can do the measure, and then it takes time to do the report and to give information to the pilot. So this is a safety improvement because you have continuous parameter live at any time available, and you can give at any time information to the ATS and to the pilot. And this also avoids, of course, disruption because you don't have to interrupt landing, and you have no problem. So this is also it's a good way to avoid delays and so on. So this is the first example. The second example I want to do is the sensor that we have in the apron, in the aircraft stand, to measure the real block-on, block-off. You know that the visual docking system that we have at the contact stand, they have sensor. They measure when the aircraft stops on arrival or where it moves on departure. And these data are sent directly to the ICDM, so it's very important. But what if you don't have the visual docking system? So what we have done on remote aprons, we have placed some sensor. We have placed 4 sensors for each aircraft stand. We place them in a way that they are suitable for any kind of aircraft. They can use that stand. And so these sensors, which have a triple functionality, they are optical, they are infrared, and they are also magnetic field. They detect when the block-on, block-off happens, and they send the information through a LoRaWAN and 5 antenna on the apron to a cloud, to the system, to the platform, and then these data are collected and sent for the ACDM. But they are sent also, and they're used also for the resource management system that we have. So the people that is in the airport operation control center knows exactly if the aircraft stand is still occupied or is empty. And this helps not to make stand allocation mistakes, which often can result in incident, and it happens all over the world. If there are 2 aircraft that enter into stands which are not compatible with the clearance, and so this is also another way to also increase capacity, because you maximize the utilization of your stands. If you have few stands, you can increase capacity utilizing more your stands with this system. Last example regards the electric field mill. Electric field mill is a technology that, with special sensor, electrostatic sensor, measure the electrostatic intensity in the atmosphere when, for example, a storm is arriving at the airport. And this kind of technology, together with the, let's say, the lightning system that reveals the place where the lightning bolt hit the perimeter of the airport, are a very useful tool for example, for the duty manager. Because for example, according to our risk assessment, when a storm arrives, if a lightning bolt fails in 3 kilometers, inside the perimeter of the airport, you need to stop the refueling of the aircraft. And this has an impact, of course, on the delays and on capacity. So what we do with this system, and thanks to this sensor, we have 2 sensors for each airport, we know we can predict the risk, the potential risk of lightning bolt inside the airport, and we can reduce the safety buffer time that we have, for example, which is, in our case, is half an hour, and we can reduce it, and we've seen we can reduce it up to 70% with this tool. So these are 3 examples.
Thank you very much, Alessandro. Thank you for pointing out that actually digital transformation is more than transforming paper into 0 and 1s. And safety and efficiency actually go hand in hand. That is very interesting. We'll get back to that when we finish. My next 2 panelists are flying in tandem, multi-crew here. And we have a good example of an ASP and academia working together to do great things. And we have Emilia Kozinska from the PANSA, the Polish NSP, flanked by Dr. Jan Malawko from University of Warsaw. And it's follow-up on the discussion we already have with Alessandro. We are increasingly data rich. We have data at our disposal. But does this make us really smarter? Are we getting the information out of this data in a way that is bringing more efficiency, more safety? How are we using machine learning and AI to bring this additional value to efficiency and safety? And I know you have a presentation, and you will need a clicker for that. There you are.
Thank you. Thank you, Eduardo. Thank you, Alessandro, also for a perfect introduction, because our project is really focusing on the runway monitoring and runway condition reporting. So basically, we are using what you exactly described, so the built-in runway sensors that are covering each third of the runway to be in line with the new GRF, and also the new meteo stations that we have put in place into the airport that we have been testing the system on. So having all of this information, data about the runway, about the contaminant type, depth, and coverage, supplemented with the weather information, weather forecasts, we have created a system that is computing all this information and translating it using the GRF matrix into the runway condition code, and simply giving the duty officer the computed runway condition code ready for being used in the report. There's also a chance, of course, for the duty officer to manually change the runway condition code that was suggested by the system, using their own experience or another data, whatever they can that can be trigger for downgrading of the runway condition. And as an additional independent source of information, we are also using an OVAC system. This is an onboard braking computation system. We have 2 kinds of this. One is the system developed by Airbus, which is automatically reporting to our system. So the duty officer knows exactly at the same time what was the braking action of the just landed aircraft. And within our project, also Dassault has been developing their own system for biz jets. This system is supporting the pilot with precise figures to be put it in the PIREP if such report is needed. And then with the conventional way, it goes through the tower controller to the duty officer. So what more our system is giving also the prediction of the future runway condition. So we have two figures. One is the current situation on the runway, and the second is the trend, how it will change during the next hour. And what the system allows also the duty officer to report and code the runway condition report directly from the mobile devices that they are equipped with, so they don't have to go to the offices to switch between the systems to code the runway condition code, to code the snow time, etc. So it directly goes from our system to the tower controller, to the dashboard, and the same goes with the snow time. If it's needed, it goes to the NOTAM office, send it, and that eliminates a workload and fasten the time and the producing of the snow time and runway condition report. What is important, this is the R&D project that is this EASA project that is on V3 maturity, and at the end of the validation, there was the result that the dashboard that is dedicated for the controller, it's actually the results shows that the research should go further, and the integration between ATIS and our AirCam system should happen to automatically update the figures in the ATIS. On the airport that we've been testing, it's the tower controller responsibility to update the ATIS. So such solution will eliminate the workload needed for that. And of course, that depends on the agreements between the companies. So it might be the workload of duty officer which will be reduced, but this is the further steps that should be ongoing. I think this is how the system for the duty officer looks like, with all the information. And the bottom you can see the OVAX figures coming from last landing planes, and current runway condition code with the tendency and the information about the accuracy of the prediction. So, and further you can click and change the visual to see the graphics and all the figures coming from the sensors and so on. So duty officer can always check how it was computed.
Okay, it's my turn. Thank you very much, first of all, for the invitation to this conference. As the representative of academic institution, I would appreciate and I would mention that this has been a really privilege for us to take part in this project, because it's really challenging, practical project, not purely academic project, theoretical. So we had the opportunity to really see and compare the results of our computation at the airport, and compare it with and discuss it even with the crew. So it's really challenging for academia. With this diagram, I would like to present the data processing of the information we have to compute and predict the runway condition code. First of all, we collect the MET information, AVOS information, ICE alert information from the runway sensors on our data repository and data processing center, and together with MicroStep. Then, additionally, we receive the information which is very important from the aircraft which just landed, which is the OBAX system mentioned by Emilia previously, which is the onboard system which is computing the current situation of the braking action. So we collect those data as well. And we apply the machine learning algorithm in order to predict and to estimate the current and the future, the nowcasting, the short-term forecast for the runway condition code. we transmit this information to the airport, to the tower, and this information is then sent to the landing aircraft with high accuracy, receiving the information about the real condition. And this information also is distributed for the airport services in order to assure the proper airport handling, especially during the winter conditions. So basically, this is the process. As you can see in the process, there are, in this illustration, there are many players starting from the airport, ANSP, aircraft manufacturer, aircraft operator, and at the end, data processing and data repository centers. So the value of the system is consists in good relation and good interfaces between those institutions those entities who provide different kind of data, and we combine them, and thanks to this we are able to generate the proper report. Next slide, probably. So in summary, this solution is based on the novel machine learning algorithm. This solution has met the challenge of high dispersion of runway contamination due to rapid changing in weather conditions. Can estimate for these circumstances. Can be customized to any airport with different locations, geographical, weather conditions. So it's also additional value. It can generate accurate no-casting prediction for 1 hour with 10 minutes interval, but this can be tuned according to the local needs. It resulted in systematization and creation of database based on the current ICAO global reporting format, which is the current format in this respect. Of course, there are possibilities to generate a dedicated dashboard or automatically generate ATIS using this application. We also managed to validate the system using the safety assessment for all abnormal situations we were able to predict. And finally, this project can result in and can be the inspiration for the implementation of artificial intelligence machine learning algorithms in other airport operations areas. For example, here can be extended into the rapid exit taxiway estimation, which is also very important due to potential excursion during the winter conditions. So basically, it's very inspiring and is promising project, I think, and is basis for the future projects in this area.
Thank you very much, Emilia and Jan. Congratulations for the partnership. This is how it should work. It's also two takeaways, indeed, data and automation making processes more accurate and more efficient. And also what I like is making sense of different data sets, make them work together to get better safety and better efficiency out of it. Moving on, we have a local girl, a hockey fan, but that now has traded the local beer for the cold winters of Montreal, where she's Director of Ground Operations for IATA. IATA is not being involved in the operation of airports, but of course representing, 300-odd airlines with a global footprint. You have an interest in sharing best practices and making sure that those are adhered. In the end, operations is where the risks tends to concentrate. So of course, you don't want this type of risk transfer coming from the ground up. Can you tell us what IATA is currently doing in terms of enhancing safety in ground operations?
Absolutely. Right, you are. Thank you. It's a slightly different position that IATA has, because any solution that we develop or put in the market, it has to definitely be implemented globally, which means that for us, we want to make sure that the solution is the same in Rwanda, Singapore, or Peru, and that's become a challenge. Yeah? if I oversimplify it, we do two things. We develop a global standards, and we are the driving force behind their implementation. So we make sure that the standards are globally implemented all across the globe at all the airports, in collaboration, of course, with airlines and ground service providers. What we are trying to change are, couple things. Of course, definitely, we would like to reduce the paper documents. Yes, so going digital and making sure that there is a significant reduction of all the paper forms and tables that we have today and we use today in ground operation. Limited communication, so making sure, of course, that the ramp is connected. We still have, of course, a lot of old ground support equipment, GSC design, so we are trying to address it with enhanced GSC. Making sure that we have a real data informations, and then, of course, that we collect the data, analyze them, and make a decision that are data-driven. Of course, we are also working with the airports addressing inadequate infrastructure, and, of course, looking at the environmental aspect. In ground operation, it's a lot of course, CO2 emission coming from the ground support equipment. It's also, for example, noise reduction. What are the solutions? A solution that IATA is looking at the request of our members, the airlines, but of course also in collaboration with the ground handlers. It's definitely use of robotics and standards that can be applied for utilization, design, development, testing of the robotics. It's also, of course, all the tracking and mobility, because we want to track employee and staff, making sure that we have a smart software solutions that collect the data, analyze them, apply artificial intelligence tools, and then we can see where we have some bottlenecks or where we have mishaps and gaps and inefficiency that we need to address. And of course, developing also a new digital standards, because today it's not enough to have, for example, the ground operation manual and all the standards for coning, choking. You need to have it in a digital form, because that's the only way how the software providers can work with that. So to give you an example, we are developing standards for autonomous vehicle operation. So we are focusing on ground support equipment, and what we did, we divided the autonomous vehicle operation into 3 phases. So it's a movement from point A to point B, so it's a straight line movement, very simple movement. The second phase is maneuvering in restricted area, so it can be in the ERA, it can be in a cargo warehouse, it can be, for example, in a baggage area. And the third phase is, for example, operation of the GSC, so when really the ground support equipment is approaching the aircraft. And then, of course, each of the phase we have to do a risk assessment, and we have to define the standards that the developers of the autonomous ground support equipment can use. So we are talking about what are the rules to follow for driving, for stopping, entering the traffic, leaving the traffic, recognizing obstacles, crossing the taxiways, So there's multiple standards that you have to develop. And then we partner with some smart, colleagues from Silicon Valley, for example, and we test it at the airports. And then we find issues, mistakes, things that we never thought about, and then we go back and redefine the standards and test again and look at the data, and of course trying to make sure that it can be work. And once it is done, then we publish it in our documents, manuals, and share it across the world. Another example that speaks for itself, it's of course damages. We all talk about the aircraft damages, and it's a significant, of course, cost for our airlines, but also ground handlers. We look at the damages, and it's probably no surprise that majority of the damages is happen through the incorrect operation of ground support equipment. It's happening on the ground, and it's a human errors. The ground support equipment must be somehow enhanced. So when we were looking at the data again, it doesn't come as a surprise that there are 4 types of equipment that cause the major damages. It's the belt loaders, it's the cargo loaders, it's the passenger stairs, and boarding bridges. And when you look at all these equipment can be easily enhanced in a way that they can be equipped with some kind of telematics or sensor or anti-collision system that basically are able to detect and prevent the damage caused to the aircraft. So we developed the standards. Again, the standards are published in our Bible, in the Airport Handling Manual. Of course, it's also about the maintenance and training, and then we test them. So we partner with some key service providers and airports, and we test and collect data how many times the ground support equipment movement, the signal went up and it prevented a damage. And of course, then for example, we develop a formula that calculates the damage saving utilization of those sensors. And again, then we share the data and try to advocate for global implementation of enhanced GSE. Another example I can mention is digital standards for aircraft turnaround. What we have done, we have mapped the aircraft arrival and departure, so basically the entire aircraft turnaround process from A to Z as written in the ground operation manual that we put together with the industry subject matter experts, and we turn it into digital standards, and again, partner with providers that develop a software that is able to monitor the aircraft turnaround process. So we define different data points, different data collection, messaging exchange, and at the airport where the gate was equipped with a camera system, so we monitored the entire process and we could see exactly where are the bottlenecks, what is the delay. We were able also to, for example, monitor a compliance, because in the software you can easily define how many cones you have to have. We talked about that in the previous sessions, or FOD, some of the simple processes. You can define, proper choking, or even proper, shape of the chokes, and all the information about compliance, you can go through the software, so you don't anymore need to send auditors on site. You just basically need to sit and analyze the data, the software, and you exactly see where some of the, again, non-compliance, unsafety practices are and what needs to be fixed. So if I summarize it in general, this is how the aircraft turnaround looks today. So you can see, of course, definitely it's a heavy manual process, very much related to skills of our staff and employees. And of course, what we are trying to, sorry, I went too fast, I want to go back.
Do mine as well.
Yes. No.
We're done, thank you.
We're going too fast.
Too fast, yes, yeah, that's my case usually. Apology for that. No.
This will come later.
The colleagues from the IT room, can they
I'm doing
move us back a little?
Okay.
Voila.
Thank you so much. Yes, thank you so much. So, and the next slide, please, if I can ask, and then I better hand it over to someone else. The next slide shows you how the aircraft should look like in the future. So it's a lot about having all the sensors, the telemaxing, collecting data, analyzing it, having artificial intelligence tool, and basically trying to drive, again, safety and efficiency.
Thank you very much, Monica. And I know you did it on purpose to show that technology has to be handled with care.
I wish.
I took as my main takeaway from your presentation is about standardization. We'll get back to that. But you also brought up an important point that is linking to the next colleague, Øyvind Hallquist. He's a senior advisor on strategy and international affairs with Avinor. Thanks for joining us from Oslo. I saw you already got your first snow there, not too much to prevent you from coming. But you've been experimenting there with interesting solutions in terms of unmanned snow removal vehicles, speaking of what Monica just presented. But tell us what led you to take that decision to consider developing a solution and implementing it.
In Avinor, we're always looking for new solutions to improve efficiency and performance of our airports. Of course, we are an airport system with 43 airports of very many different sizes, from the very small 800-meter runways with just a few thousand passengers a year to Oslo Airport, which in 2019 had about 27 million passengers. And quite some years ago, about 2010, we started, we got whiff of this autonomous technology for snow clearing vehicles. And we started looking into that, and we quickly saw that it had quite a good potential for improving efficiency at the airports. But we saw there were quite a few obstacles also that had to be passed. So we started developing scale models, and that turned out well. So we had to move to full-scale testing, and the full-scale testing also went well. So we started testing at Oslo Airport in 2018, and then all this testing showed us that this is really a very good business case as well. So we made the decision then in 2021 to enter into an agreement with the suppliers of the equipment, Øveraasen and Yeti Move, to supply 12 autonomous snow clearing vehicles to Oslo Airport. They were delivered this year, and now they're in position and ready to be used. And you mentioned that there's already been snowfall. Yes, last weekend they had their first test, and it turned out quite well for the first test. So some minor snags were removed or identified and then removed, but this is looking really promising. Now, when we decided to move into autonomous snow clearing vehicles, that also paved way for a decision to go into what we call a wide sweeper concept. That means that in the past we used 8 vehicles, 5.5 meters clearing width per vehicle. Now, using the autonomous vehicles, it gave us the opportunity to go with even wider vehicles, 7.5 meters wide, and then reduce the number to only 6. So this is already quite an efficiency gain at the airport. So the benefits are many. I can talk at length of these. We might get into them later through some of the questions. But of course, they provide a higher accuracy with the autonomy. There's increased efficiency. There's also the safety aspects. I'll talk a little bit about that. And increased predictability and monitoring and reduced cost is quite an important point, because that's the enabler to be able to go into this project. And increased comfort for the drivers, not the least, because some of the shifts, they run up to 12 hours to clear the snow during a snowstorm. So to be able to ride more comfortably is a good benefit. Now, some of the safety aspects. What makes autonomous plow trains more safe? Of course, now the authorization points are automated. The monitoring from the tower position, the air traffic controllers, is greatly enhanced. And the safety barriers are now identified in the system. And we also have in the system a remote emergency stop, which is a feature that we did not have with the manual snow clearing vehicles. So there are some challenges still that we're working on. One of this is, of course, the drivers, the operators. They have to have a transition from being an active driver, and now when the vehicle drives itself, to be more passive, but also able to react quickly to any incidents that occurs. And there's also, we're working still on trying to improve the planning and the preparedness in the event of failure of the system, or if a machine without the driver breaks down. So to mitigate this, we have established a support team that are dedicated with experts, and we also establish routines for to revert to manual operations if the system fails. And we're working also to identify the risks, the functional risks in the software. This is something that we're doing now the first year we have this system in operation. So now I have a short video just to show you what this is all about, so you can enjoy that.
When you think of operations at airports, 3 words come to mind: efficiency, reliability, and safety. And the world's best-run airports are always looking to improve. And nothing can disrupt an airport more than a snowstorm.
The technology for autonomous snow removal is here today. The big advantage with autonomous snow removal is that you get a consistent operation, it's a safer operation, and it's also possible to reduce cost.
We harvest knowledge from the experienced snow removal operators, and we program that into our system so that we can automatically remove and clear snow reliably and accurately.
One of the main features of Yeti Move's software platform is the planning module, which lets the user create a detailed plan for a set of machines when clearing snow at the runway.
We are currently operating 20 vehicles at Arlanda airports and 12 vehicles at Gardermoen.
At Avinor, we need to be in the forefront of the technological development. The advantages of partnering with Yeti Move and implementing autonomous snow removal is greater reliability and accuracy, reduced costs, and good oversight.
Development of autonomy is going fast and it's coming on more areas, for example, luggage handling and passenger transport, so it will be a part of the future.
The product that Yeti Move has developed can be used in different industries.
As the need for greater efficiency increases, Yeti Move's autonomous solutions are the answer for a sustainable future.
Excellent. Thank you very much, Oyvind. Very good stuff. The future is now. We see it with you in Poland, in Italy. So we don't need to wait for the technology to miraculously appear. It's here, just making sure we make good use. And speaking about making good use, we have Markus Schnabel, Senior Vice President for Safety in the Lufthansa Group, who I think among the 11 AOCs you have now, you fly to some 250 airports around the world. And looking back, aviation safety is built on predictability, on standardization. How do you see all these developments from the other side, from the cockpits, and having to keep up with all the systems and the quirkiness and the peculiarities that they all bring?
Yeah, thanks, Eduard. And maybe I first take the opportunity to say I'm quite impressed because it's 5 o'clock and the room is still completely full, so I really like the safety community here. And I'm a little bit sorry that I didn't bring that many nice pictures and tools, and I promise the next time I will have some with me. So with this said, I once in a while also have the opportunity to be even on board of a flight deck or the cockpit because I'm an active pilot as well. And I just thought about the last 20 years of flying, and there are some kind of positive examples and developments, and this year on my right-hand side is a very, very good and a very positive one, and I think we should be proud of those positive examples as well. And but maybe I answer your question with, let's say, three topics, 3 items. And there's a proverb which I really, really like, and I'm really into that, which is if you want to go fast, go alone. If you want to go far, go together. And there's for sure a lot of need to go faster than we did maybe within the last 20 years. But on the other hand, I see quite a lot of local solutions, and which make especially our life as pilots much more difficult than it should be. And to tell you a little story, I think it was some months ago when I visited a fair, an industrial fair, and I had some time and I walked around to the different booths. And the interesting was that there's at almost every booth, there was, let's say, something like a cooperation, but a quite local one, maybe of an ANSP or an airport or a ground handling company. And they had a pretty cool and smart local solution. And they envisioned it that it should be rolled out to the others, that they can sell it to other airports, for example. And then I went to the next booth, and there happened almost exactly the same. And it was almost the same idea, just with a little different twist. And it went on and went on and went on. And at the very end, I asked myself, if everyone has decided for themselves, they go for the make decision, who is then in for the buy decision, and how can we scale up all these local solutions? So that's maybe the first insight from my side. I think we need a clear envisioning to go together across Europe for this kind of solutions. We need a higher degree of collaboration, and from my perspective, for example, EASA and EASA 3 and so on is a good, let's say, starting point in many aspects. And we need even consortiums, because, for example, if you go to other industries, like the shipping industry or the automotive industry, I think they are quite ahead of us. For example, if you go to a harbor, you go to Rotterdam or you go to Hamburg in the fancy terminals, there's quite a high degree of automation, and they use this kind of virtual possibilities to find FODs, and they even check with the cameras if you're wearing your yellow, beautiful jacket, and so on and so on. And I think this could be also solutions for us, and via this kind of consortiums, we can get the let's say, the not funny part of innovation management done, because we all know innovation is made of ideation, and I think there are a lot of good ideas and visions out there, but the not funny part is the implementation part, and there we have to speed up. The second answer on your question is maybe the reason why. Why do we have to do that? And to give you a little insight in that one as well, for example, in Germany, 1963 was the year with the most childbirths in history. And now, 2023, basically next year, is 60 years later. And as you said, crises are sometimes catalysts for developments and innovations as well. A lot of people have left the labor market due to the corona crisis, and they won't come back. And in the year 2021, that was the year with the lowest population in the age of 16 to 25. So we definitely have there a gap of, let's call it, labor forces. And when you look in our industry and in airport safety, to bring it on the broader picture there, then you can see what happens if you don't have enough people to work for your ideas. And that happened basically last summer as well. And so we have to find at least some ideas to bring the workforce up. And I think there was a question on the panel before up there. And of course, it could be an opportunity or a possibility to pay more. But basically, it's just a demographic change. So there won't be more people within the whole system. And we as Lufthansa Group, for example, we are hiring now within this and next year 20,000 people. And so basically, if someone of you is looking for a job, it could be a good opportunity to work for Lufthansa Group. And this is, of course, one thing where we can get more people. And the next part is, can we bring the demand down? So that's basically the main reason for the digitalization and digitization topics. And next to that, we might have workers which are not that experienced, which won't stay that long for the different companies. So we have to find smart solutions on a digital base to set the safety standard and the quality standard we are looking for. And that basically brings me to the last part, because we're so, in many aspects, silo-mentalized. So the airports, the ANSPs, the regulators, the airlines, and we have to get something what I call the shared mental model across everyone, which is then data-driven, and we have to share the information, and we have to build up on this one. For this, of course, we have to have some kind of technical or, let's say, IT experts on board, which are not maybe our local colleagues, but maybe the big giants, to drive this on. And then at the very end, at the third part, we have to share this information really to the last one, to the frontline workers. And I, as a pilot, for example, I really like it if you find those kind of solutions which come up and are visualized in your flight deck as well. And maybe just to give you a very small insight on that one, because what I definitely don't like are across Europe, all the de-icing procedures. It's chaos. And if I go to an airport, I'm sometimes even lost. How is the situation now here, and how can we handle that, and so on and so on. And that would be, for example, a good idea to standardize that topic and to bring maybe a little more of IT tools to that one as well. But on the other hand, for example, where there's an airport which made a tremendous idea and implementation of the idea to reduce the complexity in a very simple way. And for example, as a pilot, where do I like taxiing most within Europe? Any idea? Which is my favorite airport in terms of taxiing across the apron and the taxiways? How to go? Oh, they made the biggest mistake of my life.
Yeah, no.
Other ideas?
München.
Yeah, that's my home airport, but unfortunately not.
Doesn't count.
I heard there are some colleagues of Zurich is there as well, but it's unfortunately not Zurich. Hi? Sorry? It's London Heathrow. Yeah, because this airport is huge and super complex, but it's so cool because when you arrive there, they just tell you, follow the greens. And you just follow the green lights to your parking stand and it's all done. And of course, I know not every airport can have this kind of solutions, but that would be maybe a good idea, smart solution. How can we bring this in a digital way to the flight deck? The clearances of the ATC and apron providers to the flight deck visualized like in every simple car or other industries maybe. And this just as a little input and maybe a quite long answer in 3 steps for you, but that's basically the input from the airline side.
Thank you very much, Marcus. I think my takeaways is that innovation is not a nice to have, it's a must have. It's a matter of survival. And there are many ways of innovation. Some will have local flavor and will remain local because it makes sense to have them like that. The more integrative they are in terms of the number of stakeholders being affected by that innovation, more standardization is welcome in that sense. Thank you very much for very good pitches that we all have in terms of scene setting. I have a number of questions for the follow-up, but don't let me have all the fun. You have, again, top performers in terms of safety professionalism here. Take up the Slido app and put your questions there. You know, you can vote them up in terms of how much you believe they are relevant for you. They will certainly help us to get the most out of the panelists. But before we open this part, I have a few follow-ups of my own. And one is about, and is addressed mostly to the airports that were here. But kind of following up from what Marcus mentioned is how can this solution be scaled up? And what is let's say, the major problems in commercial implementation and exporting them beyond the airport in Milano, in Warsaw, in Norway? We'll start with Alessandro first.
Well, I think that one of the most important issue is related to the, let's say, certification of the technology. Sometime, you know, if the technology, for example, the sensor that we install are compliant to EUROCAE ED292, and that helps because this is something that makes you feel confident that the technology is reliable. So I think one of probably the most important thing is I think to be able to expand the technology must be reliable, and if its certificate is better.
Thank you.
I think that with the implementation of every smart solution, there will be a problem with the data sharing. We didn't face it really much because we are working as a consortium and we are co-financed by European Union, and that makes that makes it really easier. But in the real life, separate companies, they are having their own systems, and to make the system work together and exchange the information, it would be ideal to have the same format of the information and the same platform, for example. So already, covered this as a standardized services, and that for sure might be a blocker for some companies to go with the, especially when there are many companies going into the solutions. That just takes time, yes, to go and to integrate all the systems. So there are many manufacturers, so each airport has the system manufactured by another company, so it's not easy to standardize and to say that, okay, it will work everywhere in the same way.
Thank you. To pick up from here, I heard interoperability in terms of data exchange. Data is becoming an asset, and data sharing is now, I think, an important element to tackle in terms of who is then using the data to generate safety, to generate profit, to generate other data. Who is best placed ultimately, because it's going to take time, but sometimes we don't have that much time. So if we were to expedite, so we are building or we're working towards this increased standardization that allows interoperability of systems and of data sets, who should be in the driving seat towards better standardization? Monica, I see you have the answer.
I think it's all of us together, there is no other answer. It's a collaborative effort, and it must be all of us, so be it the ground handlers, the airlines, the regulators, the airports, the ATM or the air traffic controllers. But of course, it's a challenge. It's extremely challenging because we have been doing it for past multiple years, and we still haven't succeeded. We still have so many variation in different processes, and even from the regulatory perspective, definitely the FAA in US is slightly different, than of course EASA and the European Civil Aviation Authorities, or even when you compare it, for example, with Canadian Civil Aviation Authority and others. So there are differences, even in ICAO, multiple differences. All the states can file different variations. So the standardization is the challenge. I do believe that we must put all the effort to drive it. So as airlines and as ground service providers, we have to ensure that we standardize really the ground operational processes across the globe. We have some success stories here. We are still not there, but I certainly hope that within next 2-3 years, my optimistic estimate, I really think that we will be able to manage to handle the aircraft one way. And if you have one standards or one harmonized standards, then it doesn't matter that maybe you have a different local providers, because again, there must be always some competition between the organization. Each organization have a slightly different software. Someone likes Apple, someone likes Microsoft. That's normal, and we cannot stop it or prevent it, or actually we have to support it because that's drive change and innovation. But if it's developed according to the same standard, then what allows us to scale it to the level that it's global across. Regarding the data, I do believe that there is a space for regulators, so that some kind of framework can be easily defined, because we are having the multiple discussion on data ownership, on data utilization, on challenges with data handling, with data governance, with data accuracies, with structured and unstructured data set, data quality and integration. So all these questions definitely arise every single time we are implementing some digital solutions. So there is a space for framework or telling us at least what needs to be defined in place that we can move forward with implementation.
Maybe, can I just jump on that one?
Sure.
Because I think the first step is mental change, because a lot of people heard data is the gold of the future, and that's how they keep the data. And I think that we have to change around, because normally, like the huge companies, they, for example, say their IP is once in a while even open source because they want that it's shared with the world and it's an industry standard, for example. And I think as long as it's not personal data, I think we have to go this way in operations as well, and especially for the safety topics. Yeah, share the information. And then I think the regulator has to set somehow a certain standard, but wide standard, and then the rest is part of the industry. Yeah? Like filling up this with standards, because the industry normally is more flexible than if it's on a regulator base. And I think then it could work, as I said before, with some kind of consortiums and so on and so on.
All right, so we all have to work together. I was expecting that to say we were all taken care of by us, so nothing for the regulators. Joking aside, I think there is a need for the regulators to be involved, especially when it comes to the safety output of all these activities. And speaking of the regulators, there's none in the panel, but there are quite a few in the audience, and I am also one of them. How ready we are regulatory-wise in terms of having the frameworks in place and having the talent among the regulators to certify all this new technology? Oyvind.
When it comes to aerodrome equipment, of course, EASA has the competence to regulate aerodrome equipment in the Basic Act, but the regulations are not in place yet. This is work to come, I believe. In Norway, in Avinor, we, of course, when we were introducing autonomous snow clearing vehicles, we had to work with our Civil Aviation Authority, and they were very helpful. They had a practical and pragmatic approach to what we were doing. There were no regulations for autonomous vehicles as such at airports, but there were regulations for autonomous automobiles for public roads, and this was helpful to some degree. And then it was a matter of looking at the safety nets, the training requirements, the procedures that were all required for setting up the system without having any prescriptive rules available. So we were able to do it with our authority, and I think that's the way to look at it. Look at it in a pragmatic and practical way, without prescriptive rules, and that will because that will also stifle innovation. So we need to have flexibility in the way we approach the regulatory side.
Thank you very much, Oyvind. Alessia, you also mentioned working with the regulator in developing and deploying all these very interesting solutions in Milano. How was that experience?
Well, I experienced with some people from the regulation, so no, it was great, and you know, I was telling you about this trial that we did for 4 months last year, and you know, innovation comes from the Latin word innovare, which means change, but means also replace a process on or a way you do something. So we were used to do something, you know, with physical measures, but we know, everybody knows that when you change the operator that does the measure, you know, the empirical measure, often you have maybe two results slightly different. So if you find a way, you know, to, let's say, engineering this measurement with these sensors, and this, if the accuracy of the data are correct, that's what we looked for, you know, doing the trial, and if the runway condition report and the snow time are compliant with the regulation 2148, I mean, we found our authority really helpful and proactive, and they are, I think, they are proud, as we are, that we are installing this technology at Milan airports and Linate. So I think it's good.
All right, so we can build on that in terms of development. I think there was some mentioning about this cooperation and the need of having good standards. I think that is actually the crux of the matter, especially when looking at the speed of development these days in terms of technological solution and innovation. It's clear that no regulator will be able to keep up. So therefore, the focus, which so far is very much focused on the technology itself, we have a lot of technology in the rules, will be to shift from that to safety outcomes, and then the solutions will have to be, at the end of the day, developed but also standardized by the industry themselves. Now, moving a bit to the register on a topic that was slightly touched in the previous panel, but is even more obvious in the context of our panel, and was already alluded here. Monica even had a slide on it, because we're discussing about innovation, at the same time facing labor shortages. Marcus has told us that it's not a matter of economics, it's just not enough resources out there. We are competing as a sector with other sectors that are looking for the same talent on a shrinking selection basis. So the future doesn't look any brighter, not only from an economic perspective, it's just the challenge of finding those talent. And technology can be a solution, maybe not a replacement. We still believe that aviation is an industry of people and will remain like this for a long time. And don't you see a bit of a contradiction in terms about innovation in terms of as a solution to cover certain jobs, at the same time finding the new talent to be able to function and develop this new talent to be able in a changing industry in terms of having this innovation and technology available. And I saw it already popping up in the little video that Oyvind showed us about how people were having different roles nowadays. I would really like all your perspective in terms of the new dynamic and the new role of the human, so to say, in a fast evolving domain, relying on increased automation and robotization. Oyvind.
Yes, in my presentation, I talked about one of the changes that we're making. We're reducing the number of vehicles in the clearing group from 8 to 6. Of course, that means 2 less drivers, but then we're also moving to autonomy. It means when the autonomy is fully employed, which is not now, it will be when we are confident that everything works, there will be only 1 driver per 6 vehicles. So that means that there will be less people, and this is, of course, what we're always looking for to make the operations more efficient and to reduce cost. It's important for us, and especially now these days after COVID, when the industry has suffered a lot. And we've lost quite a bit of money. It's important to look at the cost aspects of the operation to run more efficiently. So and this is why we're using technology. Also, technology is not an aim in itself. It's an enabler for change. So this is why we focus on innovation and to look at solutions that will make the operations more efficient. But that means also, because manpower is unfortunately one of the largest cost factors that we have. So to be able to run the operations with less manpower also reduces the cost. But there is another aspect to the topic of human resources, and that goes the other way, and that is the availability of technical experts. We see there's a lot of competition with other sectors these days, and it's difficult to recruit and maintain staff that has the technical knowledge and the competence needed to drive the changes, to do the innovation, to carry out the projects that we need. So there's a real shortage. I think my colleague from Lufthansa mentioned that the age groups are getting smaller when it comes to the people that you need that have the competence, that are the young people, and these groups are getting smaller. So we're facing a lot of competition in that field.
All right, so it means we have to up our game in that sense, which brings me to my last question before opening the floor for questions. We've seen aviation emerging from this crisis and coping with the other ones. Resilience is a new buzzword now, and we are getting quite good at facing those crises. But at the same time, we see aviation no longer being alone in its bubble. It's more and more interacting with other sectors and other domains and other priorities of the society. I think environment is the most obvious one, that it's putting a lot of pressure in terms of efficiency, but also safety, coexistence with other priorities. Another good example is the value spectrum has, and we've seen the complexity leading from proximity of new technology, 5G rollout that has on aviation. We see a lot of new entrants into the sector, eVTOLs, electrical powered vehicle, hydrogen powered vehicle just around the corner. All that will bring a lot of challenges in integrating into a highly standardized technological industry we have. Are we ready for all these challenges? These are homegrown challenges. It's not COVID, it's not the Russian invasion of Ukraine, it's our sector growing up. And are we ready for these challenges as a sector, and how much technology can be our ally in getting ready for these challenges?
We are.
Not all at once, huh? Alessandro.
Well, you mentioned, eVTOL, so I can pick up from that, because you know that as Milan Airports, we are we have, a vision that is to contribute to the development of urban air mobility through the construction of a network of vertiports, starting from Milan and Lombardy region. And so I think that to be ready, first of all, you need to prepare, and you need to work together with all different stakeholders. This is really, really the key. So for example, to be able to operate for vertiports in time for the Winter Olympics, Milan Cortina 2026, is essential to work with our airport authority, ENAC, with the City County of Milan, with the Lombardy region, with of course, all aircraft eVTOL, manufacturer, with our team of design, with our operations, with different stakeholders. So it's to be able to use then the technology, it's needed a cooperation of all different stakeholders, and to implement this new technology, and to fight against people that is resistant toward change and toward innovation. You need to work together. I think this is the most important thing.
Working together and providing value, that's the keys ultimately.
And make the change needed.
We must be ready. There's we don't have a choice. We don't have a choice. So it's like with the pandemic, no one expected it, and we just prove how resilient we are, and how we can basically deal with any challenges. Even that that was not the example of digitalization, automation. It was a different challenge, but we overcome it, and we become stronger than ever. I think it goes back to the topic of labor shortage, yeah? Because what we need to do, we need to basically upskill our people, and we have to show a different career path and look for a different skill set, yeah? Because the skill set that we will be needing in our industry is totally different than what it was, 10, 20 years ago. And we see it today, where probably many of us, we have kids, and when you see how they play with Fortnite and how they operate, the phones, the iPads, and different games, exactly, those are basically the future of airport or ground operation, and those are the people that will be operating and designing and developing all those new technologies, solutions, software, operation, remote operation, yeah. So they are getting there, yeah. If you see them, how good and fast and smart they are, it's pretty amazing. So I'm very positive.
Maybe I can give you an answer on your question, because it's a clear no. Are we ready? No. But the interesting part is, now we try, for example, to fit those new players, let's say, in our present system, yeah? And that's what we understand as preparation for the future. But the interesting part is what kind of impulses are giving us the new players to change our system in a tremendous way. Because, for example, to quote the fair side I've been once again, there was also some kind of, let's say, technological solution of separation between drones. Because if there's quite an amount of drones, for example, over a city, there needs some kind of, let's say, ANSP service, which is definitely not done by an ATC controller, and so they control themselves with each other, and it works perfectly. And this could, for example, be an impulse for the existing system for us that changes the whole system overall. And I'm really curious about this and how it works then later on, and this can change the ANSP service overall. And are we ready for that? No, not yet, but the journey is super interesting.
Thank you very much. Indeed, voice-based ATC for drones will be a big challenge, but maybe this is what we need to change voice-based ATC for manned aircraft that we've been trying for quite some time. It's a mixed bag in terms of the level of optimism, in terms of our readiness, I could see, but at least we are not in denial. Oyvind?
Well, I could add, I think I'm more optimistic. I think at least in our company, we're doing a lot of things on the technological side. We've built a remote tower center for up to 15 airports. Now we have, I think it's 8 airports being controlled from one center. It's AFIS though, a flight information service. I mentioned the autonomous snow removal vehicles. We have a drone program in our company. We are looking at all the, not only how to integrate drones in the airspace, but to use drone in our own operations, counter drone systems, to be sure that we can operate safely with aircraft at airports, and a lot of other projects that are innovative and have a very definitive technological aspect to them. And I think if we don't go in that direction, we'll be left behind. And so the world is moving towards more technological solutions, and we need to be there, and we need to move in that direction. So yes, I think I'm not saying we're ready, but I'm not saying that we're being left behind either. We're really trying to be present.
Thank you very much. I think, and I can conclude, it's an opportunity and a challenge at the same time, like always. I think we need to see it like that and approach it from both angles. We got a good number of good questions coming from the audience, and I think it's fair to give them the importance they deserve. And the very top one there, it's, I think, on everybody's mind. Going more digital, of course, means that we increase our reliance on data. And it comes with a backflip in the sense of our increased exposure to cyber threats. And we see it not only in aviation, somewhere else, even aviation players. Jepsen had a difficult situation a few weeks ago. In other walks of life, we see these cyber threats mushrooming. I think especially with those of you that move towards higher use of data, how are you tackling the cyber threat in terms of your own resilience?
Well, I can tell you that last year, cybersecurity risk was one of the major risks in our risk map. And actually, we're updating right now the map, and now is on the top 5. So it has scaled up, and of course, all digital systems are part of operational technology, OT, and IoT, Internet of Things. So are systems that, by definition, are critical. And these systems, if are, let's say, violated, these can have an effect on your business continuity and sometimes also on safety. So we want to be more resilient, of course, to cyber attacks. So I can tell you what we are doing. We are investing a lot in cybersecurity, and we have now a system which is called Next Generation Security Information Event Management. And these systems, using artificial intelligence and all different other tools, what it does, it analyzes from different systems all millions of data and monitors to see if there are signs of malicious attacks, and so as sends alarms, alerts, and so our cyber security expert, which are in the security operation control center, which is monitor 24 hours, 7 days a week, they quickly intervene and try to take countermeasure to mitigate at the beginning the attack. Because if you if you are able to intervene quickly, you can limit the damage. Of course, all systems are designed to be more redundant, but it's not often possible to make redundancy on everything. I can give you quickly an experience that we've done in Milan Airport together with Athens Airports and Zagreb Airport, and we were 18 partner between industrial partner and technical partner. We won a project funded by the European Commission, and this project was run last year, how to increase the cybersecurity of airports. And we, as Milan Airports, we were the user, the airport, and we've done some trials, and we have done a trial of a cybersecurity attack on our resource management system. And so what we were simulating, what was happening if more aircraft were assigned to the same stand. So this SATI project, that's the name, was very interesting because it came out that this platform makes all different stakeholders work together, and it's very important if you have something in your system to inform quickly the ATC provider and the handler, and and that all the community works together to solve the problem.
So cyber resilience by design, not as an afterthought. How is in Warsaw on the Panzer side?
Actually, in all CESAR projects, the assessment of some kinds of assessment are mandatory, and one of this is a cybersecurity assessment, safety assessment, and human performance assessment. And although this is separate documents, and maybe it looks like that they can be separately done, but they are really linked together. So it's important to look at the solution as a whole, not only the cost efficiency of the system and of the solution, of the benefits, but as a whole. From the human performance assessment, it results that new roles will have to appear when the solution will be implemented. So, for example, the system operator, who will be, exactly as Alessandro said, the person or the role that is responsible for monitoring of all the alerts. The Slovakian company Microstep MIS, who produced our system, they are the manufacturer. They foreseen a bunch of alerts from any kind of cybersecurity, the failure of the system, failure of the sensor, some kind of missing data, etc. So somebody has to operate it. Yes? So there has to be a role to react on these alerts, and that cannot be the duty officer who is using the system, because they cannot stop doing the assessment and producing the reports just because the system is not working. So the same, together with that goes the procedure. So what should we do when the system is not working, the failure, the recovery procedures. So it all goes together. Yes. So we cannot, of course, be prepared on any kind of attack, but we can foresee some of them, and at least prepare procedures, how to not be strongly affected with the attack. Yes.
Okay. If I can add one sentence here, it's important, I think, from the perspective of the potential user, to design the cybersecurity from the very beginning, because we have mentioned several new applications, new innovations, like automatic runway condition code generation, autonomous vehicles follow the green, but we have pilot projects on this. But it's important to design simultaneously the security protection, the cybersecurity protection.
Thank you very much. I think the time is really not on our side. This is what happens when you have such talented panelists, and we have a lot of good stories to say. There's one question also showing that we have real experts, not only the managerial type here in the room. For the colleagues, I think, Alessandro, it's for you. It's about your sensors. What are they measuring in terms of coverage of contaminants?
Very quickly, these sensors are fully, they give all the data needed by the GRF, so they are full compliant. And what do? They measure the type of contaminants, the thickness of the layer of the contaminants, and of course, regarding the percentage coverage of the contaminants, the platform, due to the 12 sensor on the runway, it's able, to display in the airport map where the contaminant is. And as I was saying, it's detected continuously, and it produces the runway condition report and the snow time. So as a string with all the data that are required, to be compliant with the GRF.
Thank you very much, Alessandro. Thanks to all the panelists for being with us today. Very, very rich topic. I think we run the risk of having to cancel the social event in the afternoon, and I don't think anyone likes that. I hope you enjoyed the discussion. Again, we had extremely well-prepared and knowledgeable experts in front of us. So please join me, and please rock the room in thanking the panelists for the great job that they did. And I hope we'll continue in the same spirit for the next day tomorrow, with also interesting panels, also addressing some of the ground handling questions that keep popping up in some of the panels. See you tomorrow.
Thank you. Stay here. Okay, just a few last things from me. This is, of course, our final panel for today. We're starting again at 9 o'clock tomorrow morning. But for all those questions that you had that haven't been answered yet, you will have ample opportunity to catch people this evening and ask them directly. So we're continuing with the evening get-together. This is drinks and dinner, which is provided by the Czech presidency. The venue for that is Villa Richter, and Villa Richter is apparently this fantastic setting with great spectacular views over Prague. The Czech Transport Minister is taking the time around just after 7 o'clock to actually welcome us to that session. Departure from here is with buses. We have 5 buses that will be leaving, obviously one by one, from around 6:15 until around 6:30. So if you can just gather in the lobby and in front of the hotel at that time, and we will fill the buses as we go, and then you can move out there. For the return, there will be buses leaving at about 9 o'clock, 9:30 and 10 o'clock, so that you have a chance to come back a little earlier if that's what you need to do. The dress code is business casual. When we arrive, the bus will bring us to somewhere where there's a small hill with cobbles, so high heels are difficult at that point for anybody thinking of wearing them. And I really hope that you'll all join us for a great evening with great views and great company. Thank you very much, everybody. Bye-bye.